So today we'll be learning acid, bases and salts. This is chapter 2 of class 10th NCERT science. But before moving on through the book, we should first try to find out what actually an acid or base is. The definition is not given in the book, so we'll just read it from somewhere else. Acid, any hydrogen containing substance that is capable of donating a proton, that is the hydrogen ion, to another substance, right? That is an acid. Any substance that contains a hydrogen is capable of donating a proton to another substance. Now whereas the base is a molecule or ion able to accept a hydrogen ion from an acid, so they are mostly interconnected, interrelated. Now that we know the definition of an acid and a base, we can go through the book. Okay, so I'll just go through the book in an overview. We won't be reading every single line. We'll just read the important stuff. So acids are sour in taste and change the color of blue litmus to red, right? Blue litmus to red. Red indicates danger. Okay, so acids are some acids are even dangerous. Okay, some acids are dangerous. So acid turns the color of blue. Blue litmus, blue means cool, water, cool, sky, everything is cool. Blue means everything's cool, going on fine. Red means alert, danger. Okay, so whenever you have to distinguish between an acid and a base, just acid turns the color of blue, that is cool litmus, to red litmus. It indicates a sign of alert or danger, right? And base turns an alert sign, that is a red sign, a red litmus paper, to blue litmus paper, okay. Litmus is what? Litmus is nothing but a natural indicator. Indicators are those that can help us identify acids and bases. Those are indicators in this context. Okay, in this context, those are indicators. Turmeric is another such indicator. Now synthetic indicator, that is man-made indicators, are methyl orange and phenolphthalein. So okay, let's move on. There's nothing much important on this page now, because we already know what acids and bases are, how to identify between them. Acids and bases in level. Understanding the chemical properties of acids and bases. Now we'll try to understand the chemical properties. Before that, this is one important line here. There are some olfactory indicators, that is, they distinguish between an acid and base through the smell, through the olfactory functions, to the smell. Whose odor, their odor changes when in contact with an acid or a base. What are these substances? What are these indicators? They are vanilla, onion and clove. Okay, now how do acids and bases react with metals? These are the important stuff. Okay, these are the important stuff that we need to remember. You can do the activity by yourself. The activity is not that important through an understanding point of view, but it would be better if you do the activity through the examination point of view, because such activities are almost always given in the exams. So what we have to find out in here is, how do acids and bases react with metals? That is, what happens when an acid and a base react with metal, right? So they've just told us about what happens when an acid reacts with metal. They haven't told us what happens when base react with metals, right? So we'll just read what happens when an acid reacts with metal. So acid plus metal forms salt plus hydrogen gas. Here you can see the equation very easily. This is acid, NaOH, sodium hydroxide, plus zinc. Zinc is a metal, and it forms sodium zinc oxide, or sodium zincate. It forms sodium zincate plus H2. Now this sodium zincate is your salt. Okay, sodium zincate is salt plus H2. H2 is hydrogen. It is released in the form of gas, right? So whenever you need to identify now what happens with an acid and the base, it's very easy to remember. Here you write acid, right, plus base, not base, plus metal. Now one product that is significant and that comes out of all acid or base reactions with any kind of element, that is salt, right? So when it comes to acid reaction with metal, you can blindfoldedly just write salt. Salt will always be there in any kind of reaction, whether it be an acid and metal carbonate reaction or metal hydrogen carbonate reaction or acid and base reaction or acid or metal oxide reaction, salt will always come out. But you have to take care of what the other products are. In the case of metal, there is only one other product, and that is hydrogen. Right, only these other products differs. Salt always comes out. We have to just take care of these other products that come out. Hydrogen is released in the form of gas, right? Hydrogen in this case is released in the form of gas. Now to remember it easily, you can just imagine like this is a puddle of acid, right? This is a puddle of very extremely dangerous acid, and this is a metal rod or a metal bar, right? Please pardon my drawing and handwriting, they are really bad, I know. So we take this metal rod and we put it into this puddle of acid. We throw it into this puddle of acid. Now what happens? This acid, this metal starts, you must have seen in movies where there's some kind of super villain, he throws some kind of acid from his mouth and the metal suddenly melts. So imagine it to be the same situation. We put this metal into this liquid acid, and the metal starts disintegrating, the metal starts melting, right? It's just for imagination purpose. It might not actually start melting, but let's just suppose that it starts melting, and after melting obviously there would be something left on. Even if you burn something up, the ashes are left, right? So in case something is melt, some kind of puddle of that substance would be left out. Now this puddle of substance that is left out is salt, and you can also imagine that when we burn something, kind of a gas also comes out, a cloudy gas also comes out, releases out, right? So you can just suppose already that if you put this metal into this highly dangerous acid and it starts burning, then smoke starts coming out, right? So you can already imagine smoke starting coming out from this way, right? Smoke is going up like this. And what is this smoke? This smoke is nothing but hydrogen gas, right? This is the easiest way to remember the reaction between acid and metal. But you have to imagine it inside your brain. If you want to remember it. You just need to imagine that there is a puddle of acid, or there is this liquid acid, and then a metal bar is going inside that puddle of acid and it starts melting up and smoke's being released. That smoke is what? Hydrogen gas. What is left over of that metal rod? Now what is the leftover of that metal rod is nothing but salt, right? This is salt. So this is the easiest reaction in the entire chapter, I think. This was the reaction between metal and acid. Now moving on to metal carbonates and metal hydrogen carbonates reaction with acids. Okay, before we go on to understanding how they happen, or how metal carbonates react with acids and metal hydrogen carbonates react with acid, first let us try to understand what they are. Metal carbonates are nothing but metal plus carbon dioxide, right? And metal hydrogen carbonates are metal plus hydrogen, and I think metal hydrogen carbonates are metal plus hydrogen plus carbon dioxide. Okay, so you have to obviously remember these reactions. There's nothing else to it. You just have to remember it, just plain and simple. But I'll tell you how you can remember it. It's actually very easy. See, for the first reaction, this is a metal carbonate with acid reaction. What is metal carbonate? Metal carbonate is sodium carbonate here, sodiums, NaCO3, plus hydrochloric acid, which forms NaCl, that is sodium chloride. Sodium chloride is what? Your common salt that you use in dishes while cooking. That is sodium chloride, plus H2O, water, plus CO2, carbon dioxide. Now what is this reaction between? Let us first write what this reaction is between. This reaction is between metal carbonate, right? Metal carbonate plus acid. Now what would it form? Like I've told you, in any and every reaction with acid or base, salt will always be formed. So just close your eyes and write salt over here. Salt is always formed, right? This salt is formed, plus what else will be formed? Now what else will be left? Now this is one thing that you have to remember. What else will be formed is H2O, that is water. Water will also come out here. Okay, water will come out here, and one more thing that will be formed would be carbon dioxide, CO2. You don't need to remember carbon dioxide because you will just remember it, and it would come to your mind whenever you would read the kind of reaction. See, this is a metal carbonate, right? It has metal and it has carbon dioxide, right? And it is reacting with acid. So from the previous reaction, we've learned that when metal reacts with acid, it forms salt, right? So here metal is reacting with acid, so definitely it would form salt. Then there is this carbon dioxide. Where will this carbon dioxide go? This carbon dioxide won't vanish, right? It would come out from somewhere, either in the form of gas, or it will turn into some kind of liquid or anything, but it would come out. It would be there. It would be in the reaction, in the product. So here, that's why carbon dioxide is also released. One more thing that is released is H2O, that is water. So you just need to remember water. Salt will always be there. You don't need to remember salt because salt will always be there, right? What you need to remember is this carbonate, because it is being added mixed with carbonate, so carbon dioxide will be released, right? And what you need to remember is that water will also be released apart from this. Now the second reaction is metal hydrogen carbonate plus hydrochloric acid is equal to NaCl, which is again what? Sodium chloride, that is common salt, then H2O, that is water, and then CO2, that will be released in the form of gas, right? So it's the same reaction for both of them, whether it be metal carbonate or whether it be metal hydrogen carbonate. The reaction would be simple: salt plus water plus carbon dioxide. Why carbon dioxide? Because both of them contain carbon. So carbon dioxide is a definite release in it. So carbon and salt are common, right? Carbon and salt you can remember easily. It means there's no need to even remember them, since you would just it would just come to your mind while you read it. Metal carbonate or it is metal hydrogen carbonate. What you need to remember is that water is also in these two types of reactions. Now let us do a little bit of more study. Now what is this? This is lime water. If carbon dioxide is passed through a solution of lime water. What is lime water? Lime water is nothing but calcium hydroxide. Okay. So lime water is calcium hydroxide. Now if carbon dioxide is released is passed through calcium hydroxide or lime water, what would it form? It would form white PPT. And what is white PPT? It's calcium carbonate. And what else would be released? H2O. Why would H2O be released? Because this was lime water. So water is also present in here. Water would go somewhere. Water would be released through some means. So water would be released. And what else would be released? Calcium and carbonate. Carbon dioxide would turn into carbonate. Calcium is obviously also here. So it combines and forms calcium carbonate. You just need to remember what these formulas denote, and you would easily remember the reactions, right? So calcium hydroxide plus carbon dioxide forms calcium carbonate plus H2O, water. Calcium carbonate, why? Because there was calcium and there was carbon dioxide. They combined, they formed calcium carbonate. There was also water. Water needs to be released in some form, so water comes in H2O, that is liquid in the same form as water itself, right? Now, however, if excess carbon dioxide is released through the same calcium carbonate, now this is calcium carbonate here. So if we add calcium carbonate, right? And how was calcium carbonate created? Calcium carbonate was created through by releasing carbon dioxide gas through calcium hydroxide, right? So calcium carbonate is nothing but calcium hydroxide plus carbon dioxide, right? That is, it is lime water plus carbon dioxide. So CaCO3, that is calcium carbonate or lime water plus carbon dioxide plus H2O plus water. See, this here forms the exact same reaction as the previous one. Up till this point, the reaction is exactly the same, right? This equals calcium hydroxide plus carbon dioxide, right? Now we are again adding carbon dioxide into it. What does it mean? It only means that we are adding excess carbon dioxide to it. And what will adding excess carbon dioxide to it form? it will form calcium hydrogen carbonate, right? I don't know what exactly it means, but I'm naming it for as of now calcium hydrogen carbonate. You just need to remember them through this symbol. Ca means calcium, H means hydrogen, CO3 means carbonate, right? So you will form calcium hydrogen carbonate. Limestone, chalk, marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. Now we can sum up the previous reaction as metal carbonate or metal hydrogen carbonate plus acid. What would it give? Metal carbonate or metal hydrogen carbonate with acid would give salt. Why salt? Because metal is reacting with acid and salt will always come out. There's no point in remembering whether metal reacts with acid to form salt or something else. The salt will just always come out, right? So it gives of salt. Then it gives of carbon dioxide. Why carbon dioxide? Because it contains carbonate, right? It contains carbonate, and in both the reactions H2O, that is water, is also released. So this was the reaction between metal hydrogen carbonate and or metal carbonate or metal hydrogen carbonate and acid. Now, how do acid and bases react with each other? I'm sure most of you must already know, but if you still don't, there's no need to worry. Just remember, acid plus base is equal to salt plus water, right? Acid plus base is equal to salt. Again, salt will always come out. But what also comes out is water. So you already know two reactions where water is released. Those two reactions of acids, two reactions of acids or bases where water is released, that is metal carbonate or hydrogen carbonate plus acid releases water, and acid plus base also releases water, and what all of them already release is salt also, right? So here it is, acid plus base is equal to salt plus water, right? It's simple as that. Now reaction of a metallic oxide with acid, you just need to remember it likewise. What is metallic oxide? Why metallic? Because it contains metal, right? Metal again reacts with acid. What will it form? It will form salt plus this oxide. It's an oxide, so it will also release water. Metal oxide plus acid is equal to salt plus water. So you can just take it as metal oxide is a base plus acid is equal to salt with water, or metal oxide plus acid is equal to salt plus water, again the same. These reactions are both the same. Acid and base and metal oxide and acid reaction are same. So they both give the same reaction. Now non-metallic oxide and base also give the same reaction, that is salt plus water. You just need to remember them. Acid plus base is equal to salt with water. Metallic oxide, you can combine them, right? Metal plus acid, metal acid, right? Non-metal base, non-metal base, metal acid, non-metal base, metal acid, non-metal base. So metal plus acid is equal to salt plus water, and non-metallic oxide plus base again is equal to salt plus water, right?